Hi everyone, I welcome you to the presentation of this lecture on operational amplifiers. By definition, an operational amplifier, commonly known as an op-amp, is basically an active circuit element which is designed to perform mathematical operations of addition, subtraction, multiplication, division, differentiation, as well as integration. So, an op-amp looks something like this. It has got 8 terminals for this one. It has 8 terminals, and these terminals have been listed there. So terminal 1, we count it from that point going round all the way up to that one. So it's 1, 2, 3, 4. When you reach this one, 5 until you reach 8, like that. So terminal 1 is for the balance. 2 and 3, there is inverting and non-inverting. Terminal 4, that's where you apply your negative voltage input. 5 is for the balance as well. 6 is the output. 7 is a positive terminal. And then 8, there is no connection there. So the symbol for an op-amp is basically that with those terminals, which are those. So from that, there are just 5 basic important pins on an op-amp, and these are the ones. Terminal 2, terminal 1 is not very important, it's just for balance. Terminal 2 is the inverting input. Terminal 3, non-inverting input. Terminal 6, which is the output. And then 7 and 4, these are the input, the negative and positive input voltages. Yeah, 8 is no connection, and then this one has no balance. So basically these are the most important. This one, those two, and the output there. Okay, so we're looking at types of operational amplifiers. We shall discuss the inverting amplifier, non-inverting, voltage follower, summing amplifier, difference amplifier, the integrator, as well as the differentiator. So in this series we are going to look at the first one, which is the inverting amplifier. So an inverting amplifier is basically an amplifier which reverses the polarity of the input signal while amplifying it. So it will be able to increase the magnitude, but it will change the polarity. If it was positive, it will become negative, and vice versa. So the circuit diagram looks like that. You've got R1 resistor connected on the input, and the feedback resistor, which is called R2 or RF in some books. The formula for the inverting amplifier is basically voltage output is equal to negative R2 over R1 times the input voltage, which is that one there. So let's look at an example. If the circuit shown below has R1 that RF is R2, R2 is also called RF. What output voltage results from an input voltage of that? So input voltage, which is VI, in some books it's written as V1. So from there, this is the circuit. RF, which is R2, has been given. R1 we have. VI, which is the input voltage, sometimes called V1, has been given. They want us to find V output, which is basically R2 over R1 times the input voltage, but there is a minus there because we're inverting it. So on our solution there, just get this same formula. V output is equal to negative RF over R1 times V1. You do your substitutions because we have everything. You're going to get negative 10 volts as the amplified voltage, because the input was 2 volts, we've amplified it to 10 volts, but the polarity will change. This time around it's negative. Now next lecture, I'm going to discuss non-inverting amplifiers. Thanks for